Today I'm going to be describing some of the main features of our final design for the SAGV team. So start at the back over here, we have two rubber pneumatic wheels, 6 inches in diameter. We have this middle station here, which is our roller mechanism. It picks up the golf balls. So if you have these two rollers here, it'll just pick it up, it'll get wedged, slide right into the cargo. We have a metal shaft back here, 2 batteries, 12 volts each, lead acid that power these 2 motors, and we're good to go.
I'm going to continue on the cool features of this vehicle. Here we have the servo motor. This controls the cargo door, so it opens and then closes, and it allows for all the golf balls to be released. Here we have a deflector, which allows for more golf balls to be stacked in the cargo design and keeps golf balls from flying out the front end. Here we have the camera. This is what drives our automation, and this detects golf balls and then tells the motors to move forward towards that golf ball. This battery here, it controls all the Arduino and electronics, which is placed underneath the frame here. And this caster wheel allows for more maneuverability of the vehicle.
Hi, my name is Byron Cheung. I worked on the gold team for the semi-autonomous ground vehicle, and I worked on mechanical design of the assembly. I will share my screen and discuss the CAD model. So what we see here is just a generic CAD, the overall CAD model for the top assembly of our vehicle. I wanted to use, the frame is made out of 80/20. I wanted to use this because of the infinite positions along the rails it has, and we can cut it down to specific sizes. From there, I got the wheels and the motors that were store-bought. I got models for those. For another major system, we have the cargo and the release system. The cargo will utilize gravity and this angled slope to release all the golf balls. And when we choose to release them, here's a rack and gear system to open the gate and close it back again, utilizing the servo motor to drive. And we printed this rack right here, attaching it to the sheet metal door, which utilizes these plastic bearings in order to slide smoothly across, reducing friction to slide along.
My name is Rivera, and my role on the SAGV Gold team was programming, electronics, and automation. Our vehicle is both autonomous and semi-autonomous. It can be controlled manually through an RC remote, and it can also operate without user input using a camera. And what we're doing is we're taking advantage of the golf ball's brightness to utilize object recognition. My particular reason for focusing on this project is because autonomy is sort of in it's past its infancy stage, but now it's becoming more prevalent in the industry. So if you look at companies like Google or Amazon, they're all investing billions of dollars a year into this kind of technology. It saves the company money, so if you think about Amazon's automated warehouses or Google's self-driving cars.
Hey, my name is Raymond Li, and I'm part of the SAGV Gold team, and my main primary roles on the team was predominantly assembling the vehicle, testing the vehicle. So in the end, this autonomous vehicle is capable of retrieving golf ball on its own, and it helps business owners, stakeholders, and investors reduce company costs and the overall operating expense for these companies. The advantages that this robot has is that it's low cost, it's environmentally friendly, and it runs on batteries. Alright, so from the start to the very end of this multi-semester long project, what really motivated me and the entire Gold team to stay on track was to graduate and to implement all the skills and the strategies that we've acquired throughout the past 4 years and implement it towards a working product. And through the midst of a global pandemic, we were able to work from home and allocate a lot more time and work in a lot more efficient manner to get more done a lot quicker too.
Hi, my name is Zachary Roemerman. My main role on the SAGV Gold team was the RC control, programming, and automation. The main challenge that we had was coming up with a final design choice In order to make that decision, we ran to Home Depot, made a rapid prototype, and when we made that prototype, we decided that one decision was better than another, so we went with that decision. The Gold team integrated all parts of the programming together we started with RC control, made sure that worked on all the motors, the whole vehicle moved. We then switched to making sure autonomy worked using the camera to control the left and right motors, getting the vehicle to move. And then once we had both working well, we combined both programs, and we made sure that both could switch back and forth well.
Hi, my name's Daniel Sixto, and my main role in the SAGV Gold team was manufacturing, assembly, and testing. So initially our team was limited to virtual meetings using Zoom, and that was a challenge at first, but we overcame that by trying to utilize our time best, have weekly meetings where we discuss design objectives. And once we came up with a design, we immediately in the second phase of our project split up into different roles.